The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Welcome to today's webinar. We're going to start in a couple of minutes. Hi, everyone. Welcome to today's webinar, the Swiftstack Data Analytics Solution with Alluxio. We are very fortunate to have two experts presenting today. Shailesh, who is the head of product, AI ML product and solutions at Swiftstack, and Dipti Borkar, who is the head of product at Alluxio. Before I introduce you to our speakers, I have a few housekeeping items. All participants are automatically on mute throughout the presentation. If you have any concerns or wish to communicate with the organizers and presenters, you may do so by selecting questions from the GoToWebinar control panel located on the right-hand side of your screen. Just type your message or question and we will be able to see it. And we will be monitoring this throughout the presentation. We will have a Q&A session at the end of our presentation so we can answer all of your questions. Again, to ask a question, select questions from the GoToWebinar control panel located on the right-hand side of your screen. And you may ask questions at any time during the presentation. No need to wait until the end. Lastly, today's webinar is being recorded and will be available for on-demand playback from our website. We will send you a follow-up link to the presentation in a couple of days. I believe that's all the housekeeping items, so let's meet our speakers. I'd like to welcome Shailesh to start off.
Thank you, Amelia. Hey, good morning, good afternoon, folks. Thank you for taking the time to join the webinar today. We are very excited to be talking today and launching this Swiftstack data analytics solution with our esteemed partner, Alluxio. And I would now like to introduce Dipti, who is the head of products there. Dipti, go ahead.
Hi, everyone. Nice to be here and talking with Shailesh today. We have a great set of content put together for you today and looking forward to answering all your questions. Back at you, Shailesh.
Thank you. Hey, folks. So I am primarily responsible for product and solutions, been in the industry for 20 plus years. Okay. And we are very excited to be talking about this topic today. So let me quickly introduce both the companies. So Dipti, go ahead and introduce Alluxio.
Yeah, Alluxio actually started off as a project in the UC Berkeley AMP Lab. Our founder and CTO, Hao Yuan Lee, was a PhD student back then and started off Project Tachyon, which is now Alluxio. Alluxio is established as a company in 2015, and we are an Apache 2.0 open source company with an enterprise edition that we commercialize. And we are backed by Andreessen Horowitz, with the goal of orchestrating data at memory speed for cloud, for any cloud, big public cloud, private cloud, hybrid clouds, specifically for big data analytics and machine learning workloads, which are increasingly growing to get value and insights from the data that is exploding as well. And over the years, we've gotten several awards. Most recently, we were picked as the Impact 50 for big data. Shailesh, back at you to talk about Swiftstack.
Thank you. Yeah, folks. So we are about 8 or 9 years old, based out in San Francisco, with tier one investors, marquee investors like Mayfair, Storm, and so on. Unlike a lot of other startups out there, we are a profitable company. We were basically we were charted out as a visionary for Magic Quadrant in 2018 for distributed file and object storage. We are a software-defined platform, so it's a purely software-defined model. We can run on any standard commodity storage service. We have a capacity-based licensing model. Okay, and with that, let me dive directly into the solution itself. Okay, so before I dive into the solution, let me set a little context as to why are we doing this and why are we doing this now, right? So as you see in the industry, there is an inflection point, right, happening right now, and primarily driven by the edge. People call it fog computing or edge computing or even IoT, and there is this deluge of edge devices, right? So it's expected to be about 30 billion by 2020, and in fact, there are a lot of other companies who are even bullish than that number. And what that is resulting into is a huge deluge of data set, and end customers are struggling with how to store that data, and more importantly, right, derive basically value from data, right? So we are now, in fact, moving from a data-driven world to actually value-driven world, right? And what I mean by that is, well, you have all of this data. The analytics itself is evolving from descriptive, which is mostly taking stock of what you have, to predictive, which is more around what if analysis, to prescriptive. Well, I know this is what is the action I can take, right? And it's really all about actionable intelligence, right? And that's where this solution comes into play. Okay, so if you look at the status quo, I mean, what is the solution today? How are customers trying to do this, right? So for the most part, they are resulting into direct attached storage silos, right? And as a result of that, it's really they are very poorly utilized, all these silos, right? You cannot move data from one point to another. It is hindering your ability to provide actionable intelligence in the right time frames, right? So we have moved past batch world, right? And it's moving very quickly to near real time world. Okay. Also, a lot of customers are tired of do it yourself approaches or methodologies, right? The other thing we are seeing is around data gravity, which is where you want your applications and services to run where your data is, right? So though cloud provides a lot of economies of scale, as we are seeing customers using data as a strategic asset, we are seeing a lot of on-prem traction for cloud storage, okay? And all of this is, again, obviously resulting into high CapEx and high OpEx, right? So what does all of this mean in terms of, customer problem statements or customer challenges, right? So obviously, the customers are looking for not just some do-it-yourself, some of the open source tough solution. They're looking for really enterprise readiness data lakes, right, which can basically scale to a huge amount of data sets, provide the lifecycle management, provide self-healing, self-replication, geo-replication, and faster rebirths, right? So there are some table stakes requirements which the customer expects out of this software-defined storage layer. The second is around, high throughput stack. So what we are seeing is a lot of flash vendors are trying to promote flash, right? But really what is expected out of the storage layer is really high throughput, right? And, the latency aspects used to be relatively poor with an object storage. And that's why Alluxio and the solution based on Alluxio comes into picture, which now compensates for, the latency being close to the compute layer, being able to do caching at the compute layer and so on, right? And as far as throughput goes, object store and Swiftstack in particular has been able to do this, provide this massive parallelism. In fact, we have customers using this architected for 100 gigabytes of throughput for an autonomous vehicle use case, right? So that's how powerful all of this is using spinning disk, right? 10K RPM spinning disk. And the last challenge is obviously, as a result of this poorly architected DAS solutions, you result into poor utilizations, right? At the same time, the cloud costs in terms of uploading and downloading your data when it comes to at-scale data sets is humongous, right? So with that, I would turn it over to Dipti. And Dipti, if you can shed some light as to what are the trends you're seeing in the marketplace?
Yeah, absolutely. And in addition to what Shailesh mentioned, there are four big trends that are driving the need for a new data analytics stack. As the amount of data increases, the complexity of the analysis increases, there is a new stack that is emerging, and there's these four trends that are really driving the need for that stack. The first one is a separation of compute and storage. If you think about historically, whether it's databases or the big data, the Hadoop environment, the data and the storage and the compute were all co-located, in a single box, right? And even if they were distributed systems, every node, every box essentially had compute and it had storage. But increasingly, that is a paradigm that's changing. Compute is growing, and the requirements for CPU are growing significantly faster because of the nature of the analysis and the different kind of frameworks and approaches that are being used to pull out insights. And with this, you get a lot more flexibility to run compute wherever you want across many different storage systems. So this is one of the big trends that a lot of enterprises and users are moving towards, where they're looking at separating their compute, whether it's more legacy Hive MapReduce or increasingly Spark, Presto, TensorFlow, as well as the AI frameworks from their storage systems, whether it's HDFS and increasingly object stores, which we'll talk about. The second one is hybrid and multi-cloud environments. In some cases, data is so important that it would continue to need to be on-premise. And this is the case for the large Fortune 1000 companies where data is a strategic asset, and they still want to get maximum value and insights from that data. So in this scenario, a hybrid or a multi-cloud approach works significantly better, where you burst into the cloud and you have compute running in a public cloud or in a different data center on compute-intensive hardware, and you have your storage perhaps in a different place. And increasingly, we are seeing these environments, hybrid environments, multi-cloud environments, where they want to figure out, users want to pick the best approach for their needs and their business model. The third one is the rise of the object store. And it started off, obviously, with the popularity of Amazon S3, but going back to the point of large enterprises where data is very critical and having it in a public cloud is not an option, on-premise object stores like Swiftstack are increasingly becoming a norm to run data applications. particularly with technologies like Alluxio that introduce data orchestration to move the data around. Object stores can be used to run big data analytics as well as AI and ML frameworks with the same performance of the other systems. And finally, the fourth one is self-service data, which means having a culture and an environment within the enterprise where data analysts, data engineers can self-service themselves on the data within the organization. So typically, enterprises are looking at building platform engineering teams that serve out this data, as well as compute engineering teams that serve out Spark as a service or Presto as a service to make this data and the query and compute capabilities available to the entire organization. And in these kind of environments, you need a new stack which has compute separated from storage with a data orchestration layer within. So Shailesh, if you move to the next slide, we'll take a look at how the ecosystem has evolved. So as I mentioned, initially it used to be Hadoop and MapReduce. That's kind of where it began in the big data world. But today, it's a lot more complex. There are a lot more compute frameworks, and every day or every month, there's a new popular framework that's starting to emerge. If all of these need to be connected with all the systems underneath, it gets extremely complex. And that's why there is a need for separating storage and compute. And so if you move to the next slide, we'll see that
yeah, go ahead, Dipti.
Yeah, keep going. Yeah, the next slide. Yes, you'll see that the journey that enterprises are taking start off in a co-located environment where you might have MapReduce and Hive increasingly on HDFS. And then the next step two, once the clusters get more complex, harder to scale out, start reaching capacity, or the costs and the management costs as well as the hardware costs start growing are unmanageable, they start to move to step two, which is a disaggregated storage and compute. But even in this environment, the underlying HDFS may not be able to keep up with the I/O requirements of all the different compute layers and compute frameworks that the enterprise needs to support. And that's where there are many different options that enterprises are looking at. The first one could be hybrid cloud, where they take data that might be in their on-prem storage and burst that data in the cloud with Spark or Presto or other compute frameworks running in a different data center or in a public cloud. The second one is adding additional framework support. So if they're already using Hive and MapReduce, which are the first generation compute frameworks, they will look at moving to the second generation and the current frameworks like Presto and Spark or even TensorFlow, and want to do this on their existing data without making any application changes. And then the fifth one is being able to dramatically cut costs, and Shailesh will talk about it later on in the presentation, to accelerate big data. So for big data workloads, transition over to an object store, which provides a distributed capability, but still you get to run the same frameworks from the big data and the AI environment with significantly reduced costs. So if you move to the next slide, we'll take a look at. Yeah, go ahead.
Dipti, I just wanted to point out one thing, right? So the way Hadoop started for this because of this co-located environments was for a reason, right? And that was primarily because we were trying to bring compute to the data, right? So the data locality is taken care of, right? Now, as we are seeing increasingly with solutions like Alluxio and the network fabric becoming a lot more faster, that data locality issue is no longer a problem, right? And we are solving that problem, and that's really driving the disaggregation of this stacks, right? Is that fair?
Yes, so without solutions like Alluxio, you can't achieve data locality in your compute, right? Because you don't have a local data access layer that is bringing data closer to compute. But once you have a layer like Alluxio, then you don't really need storage and compute to be co-located, and you can orchestrate the data that you need It's only the hot data that you need versus actually, working on petabytes of data, right? So typically, the data that's used is most recent data, and so what Alluxio and Swiftstack together allow you to do is move that hot data, warm data closer to your compute rather than in a co-located environment where you are tied to leveraging and managing the entire data set.
Yeah, exactly. Great, thanks.
And so that's a great segue into the next slide, where you see Alluxio and Swiftstack working together, where Alluxio provides the layer on the top to integrate many different compute frameworks. And you'll see, all the popular compute frameworks that you probably use: Presto for SQL, interactive SQL analytics. Spark is widely now used more for ETL and some machine learning. Flink for streaming or ETL. MapReduce and Hive are a little bit more legacy, but also enable you to process data in many different ways. HBase, and then increasingly machine learning frameworks that are Python-based, like TensorFlow and Caffe. And all of this is enabled through many different drivers, like a Java driver, an HDFS driver, an S3 driver, a POSIX compatible Fuse interface, as well as a RESTful interface. And all of this works on data that is stored underneath in what Alluxio calls an understorage in Swiftstack, which is a highly distributed system that allows you to get native access to buckets in using an S3 compatible way. So Shailesh, why don't you talk a little bit more about Swiftstack?
Yeah, sure, absolutely. Yeah. So, folks, if you see here, what we are trying to do is get you the best of both worlds, right? So, Alluxio provides that virtual in-memory file system layer, which allows you certainly the interfaces with all these popular frameworks and applications. At the same time, on the storage side, what Swiftstack provides is really a highly reliable, available, scalable storage layer, but also in addition to that, multi-cloud data management. So what I mean by that, and I have a slide coming up talking in more detail, but it's essentially, think of this as a global namespace across whether you have an on-prem NAS box, whether you have an AWS cloud where you're doing cloud bursting, or you have GCP, right? You would be able to see a global namespace across all of these endpoints. And what it does, it allows you to keep the most strategic asset, which is the data, on-prem, while able to leverage your compute frameworks now, whether it be in the cloud and Alluxio running in the cloud and so on, right? So that's really the power of this solution. It provides you the scalability, availability, the economics of a private cloud environment with Swiftstack. At the same time, the data locality and the interfaces capability of Alluxio's on the compute frameworks. Okay, so the next slide talks about, well, where are we seeing traction with this kind of a solution, right? So there are several use cases pretty much across all verticals, but more specifically, we are seeing, use cases in the FSI industry, for example, where customers are doing, security and fraud analytics, right? In healthcare, where customers are doing bioinformatics or precision medicine or life sciences related projects. With cloud service providers doing analytics as a service or operational analytics in oil and gas using IoT or IoE, and in media and entertainment, customers trying to do customer churn analysis or sentiment analysis, right? So you can pretty much see this use case has been seen in almost all of the major verticals for leading use cases. Dipti, I'll turn it over to you.
Great. Thanks, Shailesh. So given that we've introduced the stack now with Alluxio and Swiftstack, let's try to understand where the value comes from and what each of these core elements of the stack provide. So as we were talking about earlier, with a separated stack compute and storage are no longer running in the same location. They may be running in a different data center where you have more compute intensive or compute centric hardware. They might be running in a cloud, right? But at the end of the day, for the compute, the data still needs to be moved closer to it, or it needs to run on top of the data. And so if it is separated out, then something else has to move it closer to the compute again. And this is the Alluxio layer. So Alluxio, a data orchestration platform, provides 3 core capabilities. The first one is a data locality cache, which is multi-tiered, which means that by default, it's located in memory. And so the framework, let's say Spark or Presto, is working with data coming from memory. It also supports SSDs or spinning disk so that you can tier your data and manage hot, warm, cold data closer to the compute. And this is only the data that's relevant for a specific data set within that compute framework, within that run, or for that business unit, right? The next one is data accessibility. And what we've seen is that at the end of the day, data is files or objects, right? And the same data can be accessed and processed using many different APIs and many different frameworks. The same data could be used for ETL using Spark. The same data could be used by Presto using a SQL query. The same data could be an input to a model that's doing text recognition. So it has to be made accessible in many different ways through many native APIs that the data engineers, the data scientists, as well as the data analysts can consume. And so the Alluxio supports both all the frameworks we talked about earlier, but also API translation across different protocols. For example, if you have an application that's written in Spark using an HDFS interface, then Alluxio can translate that HDFS interface to an S3 interface so that the data can be moved to Swiftstack and can automatically be read without any application changes. So that's data accessibility. And then the third one is data elasticity with a unified namespace. Alluxio provides a way for you to mount many different systems, and within that compute framework that you're running, provides a unified way of accessing all these different storage systems. So you could have that data in Swiftstack, you might have that data in HDFS, and Alluxio unifies these different storage systems and makes it available to the application without where the paths, the file paths are all maintained. Next slide, please. So here's a look at the reference architecture for Alluxio and how it would work with Swiftstack. Essentially, every application, let's say in this case we have Presto and Spark. You could have a cluster for each application. So for Presto application, the Alluxio client is a part of the application itself. It's Java. It would be a jar file that's dropped into Presto. And then the Alluxio worker that's actually managing the data blocks for objects that were stored in Swiftstack or HDFS is co-located with every instance of Presto. So in this case, if you have a 5-node Presto cluster, you would have a 5-node Alluxio cluster with 5 workers and all co-located with the Presto executors. So you have very, very tight data locality within the app itself. And when the data is needed, it is the Swiftstack or HDFS are mounted to the Alluxio worker so that they can access data across many different systems. As the application requires this data, it will get pulled in from the under storage and cached in Alluxio and made available to the application so that the next time around, the access and the latency is extremely fast. In addition to that, it is a scale-out architecture that's linear. So the more workers you have, the more you can scale out. And it's managed by a master, and you can have an HA configuration with standbys, which is managed either by a Zookeeper or a Raft protocol, which is an advanced option. And so whether it's Presto or Spark, you can have multiple compute clusters each with Alluxio as a layer within that pulls your data needed for your compute for that hot data set from Swiftstack or HDFS or any other storage system much closer to the application. We'll move on to the a little more details about Swiftstack. Shailesh?
Yeah, thanks, Dipti. Yeah, so this is a quote from one of the IDC research director, and she is trying to highlight that, infrastructure challenges become one of the important inhibitors for the broader adoption of these workflows, right? And the Swiftstack multi-cloud solution is pretty unique in the way we are able to handle the performance requirements, the scalability requirements, and so on, and the economics behind it. Okay. So on a high level, what Swiftstack is, Swiftstack has two main components. One is the Swiftstack object storage itself. Okay, and this is an on-prem object storage with highest throughput performance. So as I said, pretty much there are no bottlenecks. So as long as you have spindles behind the storage server and you have fat networking pipes, we are able to provide you pretty much line rate in terms of throughput, right? Very easy to deploy, operate, and scale. We actually came out of Rackspace, and the genesis of the open source project was from, right? So pretty much scale has been at the core of the design and architecture, right? And then the other component for Swiftstack is the Swiftstack One Space, which really provides us the multi-cloud data management piece, right? So this is an one space container which can run either in the public cloud, it can run on a NAS server, and so on. And essentially what this does is, as I said earlier, it provides you a very transparent namespace, right? So you can have your applications now, they can be moving from on-prem. If it is a containerized application, it's very common to have them move across the cloud and on-prem, right? And this makes the storage layer completely transparent to the application side, okay? And with Alluxio on the compute side, it takes care of all the latency and eventual consistency and those kind of things, strong consistency and those kind of things, right? It's completely policy driven. So we have, you can either choose the storage policies, right? Or you can choose the policies as to how the data needs to be placed, right? It can be very deterministic placement of data, where you can say, well, one of my replicas has to be on site 1, whereas the other 2 replicas can be on site 2, right? Or you can choose algorithmic placement of data, right? Metadata search is another capability. So we are very much integrated with a search engine, and this metadata search can now work across the global namespace, right? Right from your on-prem storage to the cloud to your enterprise storage as well. Okay, so very powerful capabilities between the two storage and the multi-cloud capabilities. Okay, so just going a little deeper into this, right? So let me build this slide up. First and foremost, so we run on standard commodity servers. So you don't even need a RAID card because we manage all the data availability aspects, either in the form of replicas or in the form of erasure coding. The provisioning happens automatically. We can also work with non-like components in terms of servers, in terms of drives, and so on. Okay. At the same time, we also work with large OEM server vendors, right, like Cisco and Dell and so on. So if a customer primarily is mandating for an appliance like an SKU, that's also available as well, in addition to the openness of the software-defined storage layers. Okay. Second is cluster nodes, as I said, can exist either in multiple regions, right? Just like you are used to the cloud storage. Okay, and it's optimized for location, right? The controller itself, which is really the heart of management, is completely out of band, right? So it is not there in the data path at all. It's a SaaS application. It can be hosted in the cloud or it can be hosted on-prem, right? Both those flavors are available, right? And if it is classic applications, your standard applications, for example, you have your standard BI applications which need to ingest data, they can do so with file access. So we provide NFS and SMB. Now, just keep in mind, this is not basically a parallel file system on top of us, right? So we don't provide any choke points. It's essentially what we call universal access. What that means is the same object can be accessed either through an NFS interface or it can be accessed through an S3 interface. Okay, so that's also an extremely powerful feature. And then finally, the one space cloud connector, as I said, it makes the global namespace across clouds, across on-prem enterprise storage, all of that really transparent to the applications. Okay, going a little bit more in depth, right? So as I said, replicas are supported as well as erasure codes, right? So we support a number of erasure code policies, right? It's masterless writes. So as I said, the controller is not a data nodes or object nodes, what we call them. Okay, nearest reads, again, the read is optimized for the nearest location. And when we place data, as I said, it can be either algorithmic placement or it can be deterministic placement, but we always choose as dispersed as possible to make sure that single drive or single system or even a single site is not a failure domain for you, right? Very deterministic placement with the consistent hash ring, and then all the enterprise features. So this is really an enterprise grade solution where you pretty much can expect all the fault tolerancy, right? Durability to the extent of 10 nines and above, right? Continuous auditing and continuous replication. Okay, the last slide around the product is, so as I said, one space is what really provides the global namespace or the abstraction across all of these elements, right? And again, there are, besides the storage policies, there is data lifecycle policy where you can basically clear the data. There is live migration where you can move from one endpoint to another. You can cloud burst. You can protect the data using versioning and so on. Okay. Real quick to highlight some of the differentiators, right? Not all object stores are created equal, right? So on the bottom, starting with on the bottom left-hand side, as I mentioned, truly hardware neutral. Graphies, multi-tenant support for service providers. Again, replica and erasers are supported. It's completely policy driven in terms of data placement, in terms of how your rebuilds happen, and so on and so forth. Metadata search across the whole global namespace. We also have an integrated load balancer, so you don't need an additional separate load balancer like an F5. The load balancer is integrated as part of the product, which makes sure how the data is basically round robin across what we call the pack nodes, right? Provisioning, as I said, is automatic. You can take down a node for maintenance. You can add a node. The provisioning happens automatically. The rebuilds and the rebalancing happens automatically in the background. Open source, the core is actually open source, and all the other management capabilities and the provisioning and all the add-ons are core IP, right? One space we talked about. Custom middleware is another very important feature. What this does, I mean, very often you see that the data lakes become data dumps, right? Because the data you're putting in, it's very difficult to find that data. What we allow you to do is, using this custom middleware, is be able to provide metadata tagging, right? Which is a very important feature used by a lot of our customers. And then finally, universal access, which is the file and object capabilities on the same objects. Okay, on a high level, when we looked at what are the TCO benefits on using on-prem versus public cloud, particularly for storing data set, on a rule of thumb, it's almost coming out to be 1/4 of the cost, right? So a very strong economic argument to be made in favor of on-premise. So with that, I'll hand it over to you, Dipti.
Now that we've understood the two solutions and technologies a little bit better and how they work together, it's good to take a look at what the specific use cases would be, right? As well as the deployment scenarios. The first one we look at is cloud native. And in some cases, enterprises want to deploy the entire stack in a native environment. So if you move to the next slide, let's just walk through some of these scenarios. The first one is using your existing on-premise deployment where you have Swiftstack currently deployed on-premise, and you are looking at adding and supporting some big data workloads. Typically, we see that users start off with one specific use case and one framework. So for example, it could be Spark running on Swiftstack, and you would have Alluxio that is data orchestrating movement of data from Swiftstack into the compute, and you have a cluster of Spark and Alluxio joint cluster together, where every node is running the compute and Alluxio together. So this solution is an easy place to start because you already have Swiftstack. You can now get more value out of that data by enabling new workloads and new use cases on it. You will see the same or better performance than HDFS because the data gets cached in Alluxio as well as the metadata, and you get benefits from strong consistency of the metadata, as well as many metadata operations like list, rename, etc., can be very, very efficient with Alluxio on top of Swiftstack. In addition, the operational simplicity will save a lot of cost as well as reduce overhead, and then the same resources could be used for other things. It supports a fully virtualized or containerized environment. So Alluxio supports Kubernetes, Mesos, Yarn, for example, can be run in any environment. So you could have Spark and Alluxio together. That's fully orchestrated. So you can have workloads which scale based on peak demands. You can scale it out during the day and scale it back at night, and all of this on demand while working on the data that you already have stored in Swiftstack. In addition, you could store, there is no limitation on the data set size. So you can store billions of objects, and Alluxio itself, the metadata in Alluxio is capable of storing billions of objects and files, and it scales out with tiered metadata management as well. So let's move on to the next deployment model and use case. This one is a hybrid use case. So in many situations, you might have Swiftstack deployed already in your private cloud, or are looking at an on-premise S3 compatible storage system. And so the stack of Spark, Compute, Alluxio, and Swiftstack together can enable many different hybrid cloud scenarios. So you could have the Compute and Alluxio deployed in a public cloud, AWS, Azure, or GCP, it doesn't matter. And you could have Swiftstack on your private data center. And Alluxio will mount the buckets in Swiftstack so that the frameworks on the top can directly access those. And depending on the paths, the file paths that Alluxio sees coming in from the framework, that data will get pulled into Alluxio, and then you can get significantly faster for further reads. Alluxio also supports write workloads, and so data can be written back down either synchronously or asynchronously down to Swiftstack, so that you don't have to depend on the WAN and you don't work at network or WAN speeds. You continue to work at memory speeds within your compute layer. And this is a very, very important point, because at the end of the day, your compute should be completely independent of not just the storage, but also the network. And you ideally work at the speed of memory, next work at the speed of LAN, and next work at the speed of WAN. And that's kind of the order in which you want your compute to work on, because otherwise you will have performance bottlenecks. So hybrid environments like this can be enabled very, very easily, whether it's for a public cloud or a private data center that might be separate from where Swiftstack is located. Shailesh, anything more that you want to add to this slide? Move on to the offloading use case.
Yeah, no, I mean, these are very powerful. We talked about, there isn't really, I mean, a need for HDFS per se, right? Because with the combination of Alluxio and Swiftstack, right, you now get the best of both worlds in terms of, you get the strong consistency, you get all the, improvements to your metadata operations, right? Plus you get the scalability, the elasticity, and the economics associated with object store, right? So that's what this use case is all about. It's really the offload from HDFS. And again, because Alluxio supports both HDFS and S3, you have the option of keeping HDFS for as long as you want, if you so choose to do so, right? If you want to coexist, you can do so, or if you want to migrate all of your existing HDFS to an object store for, the better benefits, you can certainly do that, right? And there are a couple of approaches you can move the data. Hadoop has DCP, which is a distributed copy, can be used as a data mover to moving from, the Hadoop environment onto S3, right? And DCP essentially, it starts a MapReduce job. It uses all the compute nodes in the Hadoop cluster to be able to move that data. It's very powerful. Alluxio also has a migration capability, which if you choose to do so as well, right? And again, this is a process which is well understood by Hadoop administrators, right? Data engineers and so on.
Yeah.
Anything
and,
else?
And in addition to that, within the Alluxio layer itself, from an accessibility perspective and a read throughput perspective, we also support replication within the cluster. So on a file granularity, you can decide if you want to have it replicated 5 times or 20 times or somewhere in the middle, and you can specify ranges, which means that even if you have the read throughput, high read throughputs on HDFS, with this capability of Alluxio, you can maintain that high throughput with Alluxio, with Swiftstack at the back. And in many cases, you could pin data that is very important. So in some cases, there are join tables where a certain table is extremely highly used across the workload. It can be pinned permanently to memory. You could prefetch data from Swiftstack and have it in Alluxio. And so there are many different approaches depending on the workload that can be supported to make sure that your throughput and your performance on a local HDFS gets maintained. And finally, if you ask about how does this actually happen, so just a little bit of a sample code here to give you an idea of what that would look like. So, for example, if you are familiar with Spark, you'll know that you typically use RDDs or data frames for processing. RDDs was the initial approach. Increasingly, data frames is what is used, and so it's very simple. In Scala, you could essentially read a text file or save as a text file, and that's the way it would work from an RDD. And from a data frame, you could use the Parquet format, which is widely used in the big data ecosystem, and you essentially read from a Parquet file. Alluxio provides that the path essentially gets it changes from HDFS : / to Alluxio : / and the rest all stays the same. And similarly, you could write the Parquet file back down to Alluxio, and in this case, you basically provide a path, and then it would get stored into Swiftstack. There are many different options on write. You could, as I mentioned earlier, you could write to Alluxio only. You could write to Swiftstack only. You could write to both Swiftstack and Alluxio in a synchronous manner, or you could write it in an asynchronous manner. And so there's a lot of flexibility based on what your performance requirements are on the workload itself. Typically, we see read-heavy workloads, so they're all reads, or 90%, 99, 95% reads, 5% writes, and it may be okay to take a synchronous write from a performance perspective if that's the case. And then mounting Swiftstack is easy as well because it's an S3 compatible solution, and so all you do is you mount a specific bucket using the credentials, your access, your secret key essentially, and at that point the metadata within that bucket is accessible to Alluxio. Alluxio mounts the bucket. It's not at this point the data itself doesn't get copied in. In fact, there's no data that's copied in. It's mostly metadata that gets read, and the metadata is cached in Alluxio, and hence any operations on metadata from that point onwards are very fast. And as the read paths come in from the framework, let's say Spark on top, that's where the data will actually go down to Swiftstack, get read, pulled into Alluxio, and served back out to the application. And once the application asks for it again, then it gets served out directly from Alluxio. And that's how simple it is. There are no, for existing applications, there are no other changes needed other than the prefix switch from HDFS to Alluxio or S3 to Alluxio for the under-storage system.
Yeah.
So Shailesh, I think we're at a good point now to move to the next step.
Yeah, Exactly. Yeah, I just wanted to point out that this example talks about S3, and we are using the standard S3 connector. Swiftstack fully supports S3 with all the latest functionalities with multi-part uploads and so on and so forth. We also have a Swift API which can be used as well, right? So just wanted to point that out here. Okay. And then moving to the next slide, just talks about, what are the other approaches at your disposal, right? So we talked about HDFS, which some of the enterprise vendors tend to be providing. And what they are is essentially an existing parallel file system which provides an Hadoop connector, right? But it is not primarily designed for these workflows, comes with all the inefficiencies it has already in terms of distributed locking and so on. Then there is a public cloud option, and then there is a Swiftstack data analytics solution, right? So if you look in terms of performance, we can now with Alluxio can almost provide good or better performance good performance, but it has a higher latency in terms of uploading that data set and when you are doing cloud bursting, right? In terms of economics, again, by far, Swiftstack on-prem object storage provides you the best economics at scale, right? In terms of deployment, right, HDFS is based on a name node architecture where all of that metadata is kept, right? So you need to provide the right availability for the name nodes. Also, with HDFS, you are providing block storage. Right, it's not elastic, comes up with all the inefficiencies, right, as opposed to Swiftstack object storage. Metadata tagging, we talked about this. We are able to provide rich metadata tagging and search capabilities, not just tagging, but also being able to search that across the global namespace. Again, same thing with elasticity and scale, right? Again, the public cloud provides good elasticity and scale as well, and we leverage them where it's appropriate, right? For example, best economies of scale for the compute layer, right? And finally, in terms of SLAs, the SLAs provided by Swiftstack object storage in terms of availability and durability are extremely high, right? Starting with 10 nines and so on and so forth, right? So as you can see, there are quite a few compelling reasons to be able to try this out. And that leads me, well, there's one more slide. So this talks about,
Yeah.
Yeah. Go ahead, Dipti. Yeah, if you want to talk about.
I mean, just say, both the solutions are really widely used and deployed. You always I kind of have a logo slide to show the how widely used it is, and I think that this slide kind of does that. Alluxio is deployed in many different environments and increasingly on top of object stores, where we see a lot of traction. And with Swiftstack getting the performance and high performance and enterprise capabilities together, they really do make a great solution.
Yeah, exactly, right? So as you can see, several market customers, right, at scale customers, right, already using us. And then finally, it comes to my final slide, right? So hopefully you guys are as excited as we are about this solution. Do participate in a live demo, talk to us. We'll be happy to do a more technical deep dive discussion between Dipti and me. And, in terms of downloading and trying it out, just reach out to us. We do have a Swiftstack, what we call Swiftstack Pico container. If it's an endpoint, if you want to do some trial and error before you actually move into deployment, okay? So with that, I'll pause you. Yeah, so Dipti, one thing I wanted to ask you was, typically, obviously you guys have a lot of these marquee customers. What are the typical deployments you guys see Alluxio deployed into? What's the size of cluster and so on? If you can talk to that a little bit.
Yeah, absolutely. I think like any technology, the size of deployments kind of varies quite a bit. It depends on the type of workload and also the existing infrastructure and the data lake that customers might have. The largest Alluxio single cluster deployment is about 1,300 nodes, but in many cases, what we see is that the beauty of the solution is that it's elastic. And so we see that very often it's not a fixed size. It actually grows and shrinks depending on the need of the organization. For retailers, for example, there are some peak seasons or peak days. And so in that case, they might scale up the cluster to 600, 700, 800 nodes, and then shrink it back down to 200, 300 nodes, depending on the time of day or the time of the year. We also see daily patterns where if there is a certain environment where Presto, for example, with Alluxio is running throughout the day, then for that environment, maybe the cluster size is large in the morning, and then it shrinks at night because at the end of the day, because of the separation of compute and storage, you no longer need to have the same size compute if you're not running anything on it. And it truly makes it very elastic and flexible. And the same compute can be used for Spark at night to run ETL jobs. And we see that pattern where a particular framework, the same instance might be used for one framework in the morning, another at night. And of course, there are many dedicated clusters where you're working around the clock, right? Large enterprises where you might have 100, 200 node clusters that's serving out many different data sets across a business unit. All these different data sets get mounted into Alluxio and get serviced by the different frameworks on top, either to BI analysts. The end application might be a BI tool like a Tableau that sits on Presto that then uses Alluxio and then a storage system underneath it. And so there are all these different types of deployments that we see. From a cloud perspective, we see a mix of all cloud in the sense all public cloud. We also see in the large enterprise, we see hybrid cloud deployments where they need the data on premise, but they want to burst into the cloud. hedge fund, well-known hedge fund, Two Sigma, for example, is a user and a customer and does that. They burst in the cloud with Spark in a public cloud, but they obviously do not want to have that data accessible and stored in the public cloud. And then the third one we're slowly starting to see is multi-cloud, and like you talked about earlier, Shailesh.
Yep. Yeah, great. Thank you, Dipti. Yeah, just another follow-up question I'm seeing here is both machine learning as well as deep learning frameworks, and what we are seeing is people use Spark for a lot of ETL processing or data transformation, and then use TensorFlow and the likes of those for deep learning. Any insight you want to share on that?
Yeah, that's a great point. As the data sets get more interesting, there's many different frameworks that can be run on the same data, right? And we see a combination of Spark, also TensorFlow, PyTorch, Caffe, that get more used on the model at the actual true model side of things. And the interfaces are different, right? For a data scientist, they don't really understand the big data ecosystem. So they are not comfortable with HDFS. They're not comfortable with, in some cases, even Spark and so on. They understand and speak Python, and they understand a file system. And that's where we see a POSIX API is actually the best way to interface with the data scientists. But what they like to do is actually combine different data sets. So you might have a data set sitting in Swiftstack, but you might also have some external data in S3, which is a public data source. How do you combine these two together, right? And so you can't, this is not their own data, it's an external data source. And so they can copy that data into Alluxio, have the data from S3 that they actually own and manage mounted into Alluxio, and then actually can run analytics and models on top of that. And in ease of use for the data scientists is is kind of the most important use case that we see. At the end of the day, they want their models to run faster so they can try out more models. And by eliminating the ETL or the data engineering between HDFS to their environment and Swiftstack to their environment, it makes it easier.
Great. Thank you so much, Dipti. Thank you, folks, for hanging in there. Hopefully, this was helpful to you, and reach out to us. And I think with that, we conclude the webinar.
Thanks, everyone. Thanks for joining today. Take care. Bye-bye. Thanks, Shailesh. Bye.
Thanks. Bye.